Welcome to In Rhythm You Lightning Talk. My name is Parag Katkar. Today we are going to talk about an important topic, which is cloud security. Let's first see why cloud security is so important. Let's start with security breach. The average cost of a security breach for an enterprise is $7.9 million dollars, with an average time of 196 days for the detection of the breach in the first place. Data security on cloud is important because you are no longer in total control. If, for example, you choose to run your applications on either a public or a hybrid cloud, you are effectively putting your trust in a third party. This means you must stay on top of things and ensure that your cloud computing provider understands this responsibility. While it's certainly in the provider's best interest to ensure top tier security for you, as the client, you have to go the extra mile. If the customer data stored on the cloud is compromised, your company will have to answer to the regulator. In highly regulated industries such as banking, finance, health, insurance, legal already have exacting standards in place. The importance of cloud security multiplies in these sectors because of all the risks involved. A data breach will damage the company's reputation and brand, but you'll also be held accountable by external parties. Loss of data. Disaster can strike at any time, be it fire, flooding, or other natural causes. This could wipe out all of your data. Unless you have safely secured and protected your data, you could potentially be at a risk of a total standstill. That's the last thing your customer will want to hear. The loss of confidence could be really damaging for your business. Accidental data leak. 40% of organizations using cloud storage have accidentally leaked data to the public. This kind of incident could compromise your business integrity and give your competition a leg up. Managing remote work. One of the benefits of using cloud computing is the sheer accessibility of data. Your critical applications can be accessed by employees from anywhere in the world. This results in flexible work arrangements and the possibility to hire staff from all around the globe. However, the downside of this arrangement is that the employees might not follow the cybersecurity best practices. If they're working from coffee shops, for example, they are using public Wi-Fi to access web. This practice entails an inherent security risk. They might also use personal laptops and phones to carry out their tasks, which means they're more susceptible to malware and phishing attacks. If a malicious virus enters your system, it'll be really hard to contain the damage. Now, let's see how organizations can reduce their cloud security risk. Let's start with secrets management. Many applications require credentials to connect to a database, API keys to invoke a service, or certificates for authentication. Managing and securing access to these secrets could be complicated, and if not properly managed, they could end up in wrong hands. Well, regardless of your solution for managing secrets, here are the best practices you should focus on addressing. Identify all type of passwords, keys, and other secrets around your entire IT environment and bring them under centralized management. Eliminate hard-coded secrets in DevOps tool configurations, build scripts, code, and more. Eliminating hard-coded and default passwords effectively removes dangerous backdoors to your environment. Enforce password security best practices, including password length, complexity, uniqueness, expiration, rotation, and more across all types of passwords. Secrets, if possible, should never be shared. If a secret is shared, it should be immediately changed. Secrets to more sensitive tools and systems should have more rigorous security parameters, such as one-time passwords and rotation after each use. Apply privilege session monitoring to log, audit, and monitor all privilege sessions for accounts, users, scripts, automation tools to improve oversight and accountability. This can also entail capturing keystrokes and screens, allowing for live view and playback. Extend secrets management to third parties. Ensure partners and vendors conform to best practices in using and managing secrets. Implement threat analytics, which is continuously analyzing the use of secrets to detect anomalies and potential threats. With the speed and scale of DevOps, it's crucial to build security into both culture and the DevOps lifecycle. Embracing a DevSecOps culture means that everyone shares responsibility for security, helping ensure accountability and alignment across teams. Next up is Web Application Firewall, which is also called as WAF. WAF provides centralized protection of your web applications and APIs against common web exploits that may affect availability, compromise security, or consume excessive resources. WAF gives you control over how traffic reaches your application by enabling you to create security rules that block common attack patterns such as SQL injection or cross-site scripting, and rules that filter out specific traffic patterns you define. Multi-factor authentication or MFA. MFA adds an extra layer of protection on top of your username and password. With MFA enabled, when a user signs in, they will be prompted for their username and password. This is the first factor, which is what they know, as well as for an authentication code from their MFA device. This is the second factor, which is what they have. Taken together, these multiple factors provide increased security for your cloud account settings and resources. Enforce multi-factor authentication for users, especially administrators and others in your organization who can have a significant impact if their account is compromised. Encrypt virtual hard disk files. Encrypt your virtual hard disk files to protect your boot volume and data volumes at rest in storage along with your encryption keys and secrets. Disk encryption helps you encrypt your Windows and Linux IaaS virtual machine disks. The best practices for using disk encryptions are enabling encryption on VMs, using a key encryption key, also known as KEK, for an additional layer of security, taking a snapshot or backup before the disks are encrypted. Backups provide a recovery option if an unexpected failure happens during encryption. Use strong network controls. You can connect virtual machines and appliances to the other network devices by placing them on virtual networks. You can connect virtual network interface cards to a virtual network to allow TCP/IP based communication between network enabled devices. Virtual machines connected to a virtual network can connect to devices on the same virtual network, different virtual networks, the internet, or your machines on premises network. As you plan your network and the security of your network, centralize the management of core network functions like virtual networks, subnet provisioning, and IP addressing. Best practices for logically segmenting subnets include not assigning allow rules with broad ranges, segmenting the larger address space into subnets, creating network access controls between subnets, and avoiding small virtual networks and subnets to ensure simplicity and flexibility. Mitigate and protect against DDoS. Distributed denial of service is a type of attack that tries to exhaust application resources. The goal is to affect the application's availability and its ability to handle legitimate requests. These attacks are becoming more sophisticated and larger in size and impact. They can be targeted at any endpoint that is publicly reachable through internet. Designing and building for DDoS resiliency requires planning and designing for a variety of failure modes. The best practices for building DDoS resilient services are ensure that the security is a priority throughout the entire life cycle of an application, from design and implementation to development and operations. Applications can have bugs that allow a relatively low volume of requests to use a lot of resources, resulting in a service outage. Design your applications to scale horizontally to meet the demand of an amplified load, specifically in the event of a DDoS attack. If your application depends on a single instance of a service, it creates a single point of failure. Provisioning multiple instances makes your system more resilient and more scalable. Layering security defenses in application reduces the chance of a successful attack. Implement secure designs for your applications by using the built-in capabilities of your cloud provider. Manage your VM updates. Cloud VMs, like all on-premises VMs, are meant to be user managed. The cloud provider doesn't push Windows or Linux updates on them. You need to manage your VM updates. Here are the best practices to manage your VM updates. Keep your VMs current. Use the update management solution by your cloud provider. Ensure at deployment that images you build include the most recent version of Windows or Linux updates. Periodically redeploy your VMs to force a fresh version of OS. Frequently apply security updates to VMs. Deploy and test a backup solution. Enable password management. If you have multiple tenants, you want to enable users to reset their own passwords. It's important that you use appropriate security policies to prevent abuse. The best practices to manage your passwords are: set up self-service password reset for your users. Monitor how or if it's really being used. And extend cloud-based password policies to your on-premises infrastructure. Role-based access control, or RBAC. Using RBAC for cloud resources is critical for any organization that uses the cloud. It helps you manage who has access to cloud resources, what they can do with those resources, and what areas they have access to. Designing groups or individual roles responsible for specific functions in cloud helps avoid confusion that could lead to human and automation errors that create security risks. Best practices for using RBAC to manage access to your cloud resources are: segregate duties within your team and grant only the amount of access to users that they need to perform their jobs. Instead of giving everybody unrestricted permission in your cloud subscription or resources, allow only certain actions at a particular scope. Grant the appropriate permissions to security teams that have the direct operational responsibilities. Organizations that don't enforce data access control by using RBAC might be giving more privileges than necessary to their users. This can lead to data compromise by allowing users to access types of data that they shouldn't have. Perform security penetration testing. Validating security defenses is as important as testing any other functionality. Make penetration testing a standard part of your build and deployment process. Schedules regular security tests and vulnerability scanning on deployed applications, and monitor for open ports, endpoints, and attacks. Keep up to date with the security recommendations provided by your cloud provider to evolve the security posture of your workload. Cloud provider services like Azure Security Center, AWS Security Hub, and Google Cloud Security Command Center periodically analyze the security state of your cloud resources to identify potential security issues. It then provides you with a recommendation on how to remediate these issues. Build an incident response plan. Preparation is critical for a timely and effective investigation and recovery from security incidents to help minimize disruption to your organization. This is how you can prepare your incident response plan. Identify key internal and external personnel, resources, and legal obligations that would help your organization respond to an incident. Create plans to help you respond to, communicate during, and recover from an incident. For example, you can start an incident response plan with the most likely scenarios for your workload and organization. Include how you would communicate and escalate both internally and externally. Identify and prepare forensic investigation capabilities that are suitable, including external specialist tools and automation. Automate containment and recovery of an incident to reduce response times and organizational impact. Ensure that incident responders have the correct access pre-provisioned to reduce the time for investigation through to recovery. Ensure that security personnel have the right tools pre-deployed to reduce the time for investigation through to recovery. Simulate incident response game days regularly. Incorporate lessons learned into your incident management plans and continuously improve. To sum it up, it's clear that although the use of cloud computing has rapidly increased, security is still a major concern in the cloud computing environment. And cloud security is just not a technical problem, it involves standardization, monitoring, policies, and many more such aspects. Well, I encourage you to check out these resources for learning more. It includes an article that I have written on how organization can reduce the cloud security risk. I hope you all learned something new today. Thank you for watching.